Now we're going to talk about the difference between the gas piston system and the original direct impingement system. While I'm doing that, I'm going to show you a diagram. So this diagram is going to represent the direct impingement system up on top and a gas piston system down below. In the direct impingement system, you can see that this is the bolt carrier in the gray. We have the firing pin. Here's our bolt. There are the gas rings, the cartridge in place, the barrel, the gas tube, the carrier key. When the cartridge is fired, the bullet travels down the barrel. Gas is pushing that bullet along, and when it gets to this point right here, this represents the hole in the barrel where, for the gas to come up in through the front sight housing or the gas block. It then travels down the gas tube, down the carrier key, into this chamber here, and you can see that this is a piston. It has gas rings just like a piston, similar to a piston in your car. And the gas starts expanding. Now, the bolt can't go forward. It's locked in place by the barrel. So what happens? The bolt carrier starts pushing rearward. Once it gets to a certain point, momentum pretty much takes over. The bullet has gone out of the end of the barrel, the gas pressure starts dropping, but momentum keeps that bolt carrier traveling to the rear, and it cycles the weapon. Now, directly below it is a typical gas piston system. Now, I want to remind you that all of the gas piston systems are slightly different. This is just a representative sample. In this case, you'll see the bolt carrier. Here's the cartridge, and in a situation like this, when it's fired, the bullet travels down the barrel until it gets to a hole in the barrel, just like the one above, except it goes up and the gas chamber is here. And this is the piston and a piston rod. So the gas expands in this chamber, pushes this piston rearward. It forces the rod back. This is all done very, very fast. And instead of it going into a carrier key with gas, it simply pushes back, and there's a lug milled into the top of the bolt carrier. It strikes that and forces it rearward. In the gas piston system, when the bolt carrier has started to go back, it starts camming the bolt due to this green cam right here, turns it slightly and allows it to unlock. Right about that point, there are two holes in the side of the bolt carrier, and I'll show those to you in just a second, where the excess gas then starts escaping. The gas pressure drops to basically zero, and the inertia is what keeps it going to the rear. In this gas piston system, once this piston goes back to a certain point, it's already smacked the bolt carrier. Inertia, momentum is carrying it rearward, and the gas will escape in a port very close by this gas block. So let me show this to you one more time using a marker. So bullets travels down the barrel, gas is following right behind it, gets that hole in the barrel, comes up, down the gas tube, into the carrier, and enters the chamber there, forcing it apart. In the gas piston system, bullet goes down, gas follows it, goes up through the hole in the barrel into the gas chamber, and it all stays right there.
Are you enjoying what you're learning? Then subscribe to the American Gunsmithing Institute's channel right now. Thanks.
Now let's take a look at them live. We've already taken a look at this particular upper. This is part of our cutaway. And you can see the gas tube right here. Gas comes up, goes down the gas tube into the bolt carrier group. Here's our bolt carrier group. You can see here is the carrier key. The gas goes through. And as gas expands into the chamber inside, it pushes the carrier back. You can see the cam is camming and turning the lug so that it can unlock. And these are the two holes that the excess gas escapes from. Now let's take a look at the bolt from a gas piston system. Hey, no carrier key. Just this large, heavy lug that's milled into the bolt carrier. Here's a representative gas piston system. This happens to be the Ruger 5.56. And you'll see that here is the gas block. The gas comes up, goes into a chamber, hits a large piston. That piston forces this piston rod rearward, strikes that lug on the bolt carrier, and sends it rearward. This one is not really held in place well because part of the handguard holds all of this in place. This is just a representative. Now mind you, every single one of the gas piston systems is slightly different. There is no mil spec. The direct impingement system is 60 plus years old. It works, and there's a mil spec to it. Every manufacturer of the gas piston system is slightly different. This is just a representation using the Ruger, but you get something like a Patriot Ordnance Factory, SIG 516, or the 716. They're all going to be slightly different. They all work very, very well, but they're all slightly different because there is no mil spec for the gas system. So what's the benefit? Well, actually they're both gas pistons. One is a piston that is internal and is on center line with the bore, so that when the gas comes in, all of the forces are linear, in line with the bore. The gas piston system using a piston rod is slightly above the bore. It could be 3/4 of an inch, maybe an inch above bore. So what's the advantage? Well, one of the advantages to the gas piston system is that there's no dirty gases going inside of your receiver. All of the gases enter this gas block, and in the case of this one, they exit right under this area, right above the barrel, and they're out way in front of you. There's all of the heat from that hot flaming gas that's pushing the bullet down the barrel is concentrated here. So after you fire a couple of hundred rounds in a direct impingement, this bolt carrier group gets kind of hot because there's been hot flaming gas in it. It also gets kind of dirty. You get a couple hundred rounds with a gas piston system and you pull the bolt out and it's pretty much as cool as when it went in. Now, on the direct impingement, your hand is up here around the handguard, and there's some heat here, there's some heat here, and then heat going inside the receiver. It's kind of spread out, and it allows it to dissipate a little quicker. In the case of the gas piston system, all of the heat's concentrated here, and it's a little bit more difficult for that heat to dissipate. It will, but it's a little bit more difficult because it's all concentrated. And I've seen the end result of someone shooting several hundred rounds through one of these and touching this gas block, and causes quite a significant burn. The gas that's blown off in a direct impingement, it comes out the bolt, and that's right near your face. Now, you can breathe in some of that carbon soot. With the gas piston, that carbon soot is considerably out in front of you. So it has some advantages, but again, because there's no mil-spec, it also has some disadvantages. One of the problems with some of the gas piston systems is because the piston rod hits above the center line of the bore. When it hits here, the back of the bolt tilts down. That can be a problem if you have the standard cam pin. It could dig into the side of the receiver. Companies like Patriot Ordnance Factory uses a roller, gets rid of a lot of that. They redesign the bolt carrier. SIG, when they made their 5.16s, actually did some engineering and made different cuts in their full auto bolts that eliminated the bolt tilt, the tipping problem. If you have a system that hasn't been designed maybe as well as those, you could end up with the rear of the bolt carrier kind of digging into the receiver extension. The threads at the back of the receiver and that buffer tube kind of digging some of the metal out. There are ways of getting around that. There are some heavy buffers that will go in and help reduce the tilt because they fit into the back of the bolt carrier. But let's face it, the direct impingement system's been around a long time and it works. So is there a need to go out and buy a new gas piston system? That's up to you. Is there a need to replace everything because this is the best thing since sliced bread? No. The direct impingement system works. The gas piston systems work. There's some really, really good ones. I've used the Patriot Ordnance Factory. Works great. I've used the SIG, especially the 5.16. They work really, really well. Kind of what it boils down to, in my opinion, Chevy versus Ford. Hey, nobody's ever going to win that debate. If you want a gas piston system, try some. Go out and, as the armor for a department, go out and try them. Have the manufacturers either send you one or bring a rep out so that you can utilize them. Make sure that it fits the criteria for the mission that you have for the weapons. If you are a civilian armor taking this course, it's up to you. It's up to your budget and how much you want to have fun with that particular weapon. They tend to cost more, but it's up to you. I say tomato. It's really up to you. I like both systems. I've used them both. I think they have their advantages. I think they have their disadvantages.
Do you want to learn design, function, and repair on all different types of firearms and become a certified professional gunsmith? If so, go to www.americangunsmithinginstitute.com and request a complete information package.